Hello students, I welcome you to my discrete mathematics tutorial in which I am discussing about the MCS 212 important topics. And in that series, today in this lecture I'm going to discuss about the Boolean algebra laws. So the first law is idempotent law, right? So this law says that when x is and or with x as is x plus x. So for your this symbols to explain is, just read plus as or, right, and dot as and, right. So this is your OR gate and AND gate. So I will explain in this video further that the logic gates, basic logic gates and the Boolean algebra laws, and and I will upload another video tomorrow and in which I will discuss about the Boolean algebra functions, and we will see how they ask the questions from these topics. And I have some previous year papers to discuss with you, and I have already discussed some of the papers in my previous videos. You can check out the playlist, right? So x or x is x, okay. And the second law, the version with AND gate is x and x, it is x, okay. So I will prove these laws for you, right? Just wait for as I go with laws and further in this video. So the second law is identity law. Identity law. These laws are same as I have already discussed previously in last video, in which I have discussed about the conjunction and disjunction and the preposition logic and equivalence. So in that video I have discussed these laws, but the contents were different, the symbols was different. Here we have plus for or and dot for and in those laws we have conjunction and disjunction and the negation, so don't confuse with that. If you look carefully, and then you can really catch the difference between these two laws, right? So that the symbols are different only. So identity law is, if I take x and then or plus 0, right, then it x plus 0 x, okay. And the another version is x dot 0, it will be 0, but x dot 1 will be x, right? X dot 1 will be x, right? Then I have third law, which is your the law is commutative law. Commutative law is very easy, as we know from mathematics background, that what is and we have already taught in schools that commutative law is very easy. It says that if I take x plus y, then it will be equivalent to y plus x, obviously. And if I take dot with or end with x dot y, it will be equivalent to y dot x, right? Okay. Now the next is your next law is your associative law, right? These laws are very helpful for solving the Boolean functions, and so you must remember these laws. It's very important. So associative law is, if I take three variables x, y and z, such that if I take the or between y and z, so it will be same as x. If I evaluate first this and then z, so it will be the same, right? And same the case with the dot operator or AND operator, right? So if I group y z first and then x y, so it will be the same. So x y and z, right? So the dot is hidden, right? If they don't use the dot, it is obviously it is dot. right? And then the fifth law is your distributed law, right? Fifth law is distributive law, right? So distributive, which is like x plus yz, the plus will be distributed to x plus y and then x plus z. Again, if I consider this in this scenario, x y plus z, then x dot y will be distributed to both these variables, right? So this is very simple laws, right? Then the most important law is which is your De Morgan's law. De Morgan's law is if I take complement of x, y, okay, you can read it as bar or complement of x, y. So it will be x complement, y complement, and the dot, because this is the AND operator between these two, so it will be the OR operator now. And the second case for this is if I take x plus y complement, so it will be the x complement, y complement, and the plus will change to the dot, or you can say the OR will change to the AND, right? Then the next thing is next important law is your absorption law, right? Absorption law. Absorption law is if I say x plus xy, then it will be x, right? And x plus y, x plus y will be x. So this is absorption law, and you can verify this as if I take this first one, it will be like x plus xy. So take x common, then it will be 1 plus y. 1 plus y will be your 1, right? As you can verify it from the first rule, x plus 1, right? X plus 1 will be 1. So if I take x plus 1, it will be x, right? So whatever symbol you use, it will be like that. And then this will be 1, so it will be x dot 1 will be x, right? And you can verify it as well, right? It is x plus y, the second case, right? This is the second case, this is the first case. So in the second case, x plus xy, we can write it as x dot x plus x dot y, right? So it will be you can take the common right here, so it will be again x plus y. So in that case, x is x, right? So x plus xy, so it will be the same as the first case. So now it will be x common 1 plus y. Again 1 plus y is 1, so that means x dot 1 will be x. So hence it is the both cases are proved. So you can prove it as well, right? Now this is all for the these Boolean algebra laws, and if you have any doubt regarding these laws, you can let me know if I can help you to understand in better way. So then see some logic gates, right? So logic gates, right? So further I'm adding one page actually, and then we will look for the logic gates, right? So logic gates means basic gates to So logic gates are basically the basic elements of a circuit. So we have any digital circuits. So the digital circuit is made up of logic gates, right? So the first and the very basic gate is inverter. Inverter is your it is denoted by this symbol, right? So it inverts to the inputs. If the input is x, so it will be x complement. If the input is x complement, then it will be x, right? So it means if you supply 0, it will be 1. If you supply 1, it will be 0. So it is inverter, right? So then we have this AND gate. AND gate is it takes two inputs. This is the symbol for AND gate. It takes two symbol x and y, and it evaluate as f. If I take function f as the output of it for this AND gate is x dot y. So now you understand the dot represent the AND gate. So the truth table for this gate is as so x y. So there will be 4 inputs, 4, because if because these are the binary gates, so it will take 2 inputs only, either 0 0 or 0 1 or 1 0 or 1 1. So this says that if both the inputs 1, it will be 1, otherwise it is 0, right? Otherwise it is 0, right? So let me put this one under this so it will be helpful to read, it will be readable, right? Now we have this another gate, is this OR gate. OR gate symbol is your this is the symbol for OR gate, and it takes 2 inputs, let's say x and y. The inputs can be x1 x2 y1 y2, whatever the symbols they use, but you must understand the concepts only. So it will be evaluated like x plus y. So that's why in the beginning of this video I wrote plus as OR gate, okay? So x plus y. So in that case the truth table for this will be x, y and f, and then again the 4 combinations 0 0 0 1 1 0 1 1. So the definition of OR gate says that if one of the input is 1, then it is 1. So in that case it will be 0 because both inputs are 0, and but here y is 1, x is 0, it will be 1. Here in this case it will again 1 because one of the inputs is 1. Here both inputs are 1, so it will be 1. So now you can verify the law, right? Verify the law that I have just discussed, right? Now we have another gate which is your NAND gate. So NAND gate means the AND gate followed by NOT gate. So NOT gate or inverter, it will be the symbol is like this. So we have 2 inputs x and y. This is the NAND gate, and f will be there your x dot y and the complement of x y, right? So then the truth table will be the opposite of the AND gate. So it will be x y, right? The f is 0 0 0 1 1 0, then we have 1 1, right? Now so if I look for this table of AND, it says that if both the inputs is 1, then it is 1, otherwise it is 0. So it will negate all the values of AND gate. So it will be if the both of the inputs are 1, then it will be 0, otherwise it is 1. So this is your NAND gate. Then the another variation of the OR gate is NOR gate. NOR gate is nothing but your OR gate followed by a NOT gate. So the NOT is like this. Then This is the symbol for NOR gate. So NOR gate is the opposite of OR gate. So the table will be X, Y, then we have F here. So 0, 0, 0, 1, again the 4 combinations, 1, 0, 1, 1. So the F will be, as we know from the table of OR gate, that if one of the input is 1, then it will be 1, otherwise 0, right? So in that case, because it will negate the output of OR gate, so it will be, so in that case when both the inputs are 0, 0, it will be 1, otherwise it is 0. So this is your NOR gate. Now we have another gate that we have left with Xor gate. So Xor gate is the symbol of Xor is this, right? So this is your Xor gate this is your, yeah, right? So it says that F is equal to X or Y, right? So it says when both the inputs are different, it will be 1, otherwise it is 0. So in that case, if I write the truth table for that gate, X, Y and F, so 0, 0, 0, 1, 1, 0 and 1, 1. So it will be, if both the inputs are same, then it will be 0, otherwise it is 1. So the opposite of this gate is XNOR gate. XNOR gate. XNOR gate is this is your XNOR gate. It is nothing but the Xor gate followed by NOT gate. So here I can this is your XNOR gate. The truth table will be the opposite of this gate, so it will be X, Y, F. So putting the values of X, Y, it will be 1, 1. Then in the Xor gate, it was that if both the inputs are different, then it is 1, otherwise it is 0. But in that case, if both the inputs are same, then it will be 1, otherwise it is 0. So right, so in that way we can define all the gates, right? All the logic gates along with the Boolean algebra laws. In the next video, I will show you I will discuss the simplification of the logic circuits as they have asked the questions. So let me show you some questions about that, how they have asked. So this is a question that they have asked in your previous year paper, which is of MCS 13, because the previously it was known as MCS 013 discrete mathematics, but now in the revised syllabus they have changed the code as MCS 212. The syllabus is same, but only the automata part is different. So this is the find Boolean expression for the following logic circuit. So this is x1, x2, x3. So this is your OR gate, this is your AND gate. These are the inverters, so you can find out the solution for this and Boolean expression for this. So this type of questions are asked. I have already solved these type of questions that have asked in your exams in my videos, where I have discussed the previous year papers discussion. So you can watch these videos, and so that's all for this video. And again in the next video I will make you learn that how you can solve these type of Boolean circuits and the Boolean functions, because the video will be so long, so that's why I have just cut it into 2 parts. So I will upload it soon tomorrow. Okay, so let me know if there is any doubt. Thank you very much.